Hi folks, I wanted to take a few minutes and do a couple of quick videos to go over the product rule and the quotient rule and the chain rule. So this video right here is on the product rule. It's probably the first thing that I look at or look at when I look at a function. So if I'm looking at a function that's given, if I'm seeing two smaller functions that are being multiplied, and that's with or without parentheses around them, then I'm thinking that I'm using the product rule because I'm multiplying the two together. Uh, it may be helpful, kind of a little tip, it may be helpful to rewrite the function with parentheses around each of those smaller functions that are being multiplied together. And remember, it's okay if exponents are negative or you have exponents running around, it's absolutely fine. So if we go ahead and we look at an example or a couple of examples, let's say I have f of x, and let's say it's equal to x squared, and it's written like this, times 5x minus 2. If I want to use the product rule for this, I can rewrite it because I have two parts, one here and one here, that I'm multiplying by each other, or however we want to say that. And so I have an x squared times a 5x minus 2. So I have those two quantities, a first and a second smaller function that's inside my big f of x function. Similarly, if I look at a g of x, let's say, and I say that's equal to 2x squared ln x, this one it's a little bit harder to see those two separate functions that I have that I'm multiplying together. But I see a function right here of x, and I see a separate one here of x with the natural log. And so I'm going to write it like this, 2x squared times the quantity natural log of x. And I notice here that I forgot my in parentheses, so I'll close that off. Let's think about another function. Let's say I have an h of x, and let's say that's equal to sine x over an x cubed. Well, I can separate this into two quantities. I could say that's a 1 over x cubed. If I don't want to use the quotient rule on this, I don't have to. Times a sine x. These are two separate things, right? And so let me rewrite this with parentheses because I have a first term and a second term. I can use a negative exponent on that first one, so I can say that's x to the negative 3 power times sine x. Let's do one more. One more would be, let's say I have a function, and we'll use a y equals this time, of 5x squared e to the x. Here you notice I have this 5x squared term, and I have this e to the x term. So again, I have two separate terms. They're multiplied by each other. And so I'm going to multiply 5x squared, and I'm going to take that quantity and cordon it off, and the e to the x gets its own set of parentheses. So now you can kind of see when you look at these, you can see that you have two separate quantities there that are being multiplied together. Right? So whenever you see these two separate quantities, these two smaller functions that are being multiplied together, we want to use the product rule. Okay, so that's the rule we're using here is the product rule because we have two smaller functions that are multiplied together. So let's take a look again at the product rule. The product rule, if I have two functions, the smaller ones, u and v, and they are multiplied by one another, if I'm looking for the derivative, and I'm assuming that they're both functions of x, if I'm looking for the derivative with respect to x of u times v, then I'm going to have my first smaller function times the derivative of the second, so u times the derivative of v, and let me grab a little pointer so you can see it. I have u times the derivative of v, and then I have the derivative of my first function times my second. I can also write these like u times my v prime and added to u prime times v. So if we want to do that for one of our first functions there, let's do it for the one that was f, if I do an example here. And so I had f of x was equal to x squared, and I wrote it like this, times 5x minus 2. So if I want to find the derivative then, f prime of x, I'm going to have my first, the x squared, times the derivative, d dx, of my second term, 5x minus 2, plus my derivative of my, the derivative of my first, d dx of my x squared term, all multiplied by my 5x minus 2. Okay, so this is kind of cordoned off all by itself. I do that by itself. So if I do the work here, I'm going to have an x squared times a 5, because the derivative here is going to be equal to the 5, plus, let's pop over here, and I'm going to say this is plus a 2x, that's this derivative, times the 5x minus 2. All right, so if I clean this up a little bit, I'm going to get a 5x squared plus I'm going to distribute into here, into each of these terms. So I'm going to get a 10x squared minus a 4x, right? And that's going to equal a 10x squared minus a 4x. And that's my derivative of f, okay? So this is kind of the way that we've been doing it a lot in class. We've been working with this method. And I want to show you another method that might be a little bit easier or more organized, that will help you take this one step at a time. So let's talk about that. Another approach to this product rule is to use a table, or the X here, the cross type thing. And we're going to define the two smaller functions still again as u and v. And we're going to make the table look like this. Now remember that if I'm looking for the derivative, I have my first times the derivative of my second plus the derivative of my first times my second, okay? So remember, this is the product rule. So I'm going to lay out, and I'm going to write down my first function, my u function. I'm going to write down my v function, and remember my original f looks like this, u times v. Okay, they're just multiplied together. So I just write down those two separate functions. I take the derivative of my u, and I take the derivative of my v, and I'm getting ready to go. So to find that derivative of u times v, which is my f function there, right? It's this function right here. The derivative of u times v, we're going to multiply across the table. So the first thing I'm going to do is go this way, and I'm going to say u times v prime, or I'm sorry, v times u prime, and so I have my v times u prime, and then I'm going to go this way, and I'm going to say plus u times v prime. So I kind of flipped the order of these, and that's okay because we're multiplying and we're adding. So I have v times u prime plus u times v prime. So we're just kind of going in a little loop there, okay? So let's see how this works. And we're going to use, again, our very first derivative there that we had as an example. And I'm going to use that my f of x was equal to a 5x. Oops, let's write it in the same order as what we had before. We had an x squared, and it was multiplied by the 5x minus 2. So now I'm going to set it up, and I'm going to say, okay, that means that if I make a little table, a little cross, I'm going to say that u equals x squared, and v equals 5x minus 2. It also means that my derivative of u prime, is equal to 2x, and my derivative of v prime, is equal to 5. All right? So now I'm going to go ahead and do my little crisscross thing, and so let me change colors here. So I'm going to go this way first, all right? So I'm going to say that means that f prime of x is equal to 5x minus 2 times 2x. All I'm doing is filling in the blanks. And I'm going to put a plus right here. So I have a plus. So I'm flipping around. I'm going to come back down this direction. And I'm going to say x squared times 5. So I'm just multiplying those quantities together as I cross over in the middle there with those lines. So I can put this together. We have 10x squared minus 4x plus 5x squared. You notice that my result here is going to be the same, the 15x squared minus 4x that I had above. So let's take a look at one more of these, or actually maybe a couple more. So if we look at the previous page, what we had was, let's see, we had g of x that was equal to the 2x squared and natural log of x. And you can see that by writing them this way, really quick, let me add a page here. By writing them this way, what I can see is that they're two separate functions. It's really easy to see which one's u and which one's v. So I'm going to make my little cross table. I'm going to say u is equal to 2x squared. I'm going to say v is equal to the natural log of x. I'm going to say that u prime, my derivative of u, is equal to 4x. Not too bad, right? And that my derivative of v is equal to 1 over x, 1 over v. My hand got away from me there. 1 over x. All right, now we're going to use that crisscross again. This time we're going to use a different color. Let's see, we'll use, we'll use blue. So I'm going to go across this way to start, and I'm going to say that means that g prime of x is equal to the natural log of x times my 4x plus, because I'm going to put a plus right here, I'm going to flip up this way and go around so that I can come back crossways this direction, and I'm going to say plus the 2x squared times 1 over x, which was really hard to see with where my arrow went there. Now let me kick the arrow down just a little bit so you can see the values. All right, so if I finish this one off, I have 4x natural log of x, and you can put parentheses around 1 or both of those terms if you want to. Be careful about dropping the parentheses right here, because if I have an x times a 4x, it's going to start looking a little bit funny. This second term, you'll notice this is equal to plus 2x squared over an x. So I can simplify just a little bit more as 4x times natural log of x plus 2x, because I can cross out 1 on the top and 1 on the bottom right here. All right, let's do another one. Let's do our h of x that we had from the previous part. And so let's see, that h of x1 was a, let's see, h of x was equal to x to the negative 3 times sine x. Appears I've changed colors. So here again, I can see that I have my two separate functions, right? I have this x to the negative 3 and I have a sine x function. And so I'm going to write, I'm going to make my little crisscross. I'm going to say u equals x to the minus 3. V equals my sine x. Here, my derivative of u is equal to negative 3, x to the negative 4. Remember, this is a negative 4 because I take negative 3 minus 1 more. So I'm going to get negative 3 minus 1 is negative 4. And then my derivative of sine x, if you remember your rules for trigonometric functions, is going to be cosine x. So now I'm going to do my crisscross. We'll do it back to purple. So I'm going to have that my derivative, h prime of x, is equal to sine x times 3x to the negative 4. I'm going to put my little plus and flip up this direction. Plus, and I'm going to come down this way. And I'm going to have an x to the negative 3 times a cosine x. All right, so if I write this, and I'm going to take these back to negative exponents back to the denominator. If you don't want to, you do not need to. You can leave these written in just kind of a combined format. So I could leave it as 3x to the negative 4 sine x plus x to the negative 3 cosine x. Or I can take those negative exponents and put them in the denominator, and I'd have 3 sine x over x to the fourth power plus cosine x over x to the third power, right? You could always go and get a common denominator there by multiplying that second term, this last term right here, by an x on the top and bottom, and I could combine my numerator terms. So I trust you can do that. Let's see, my last function was a y is equal to, here I had a 5x squared and times e to the x. So again, if I make my little table, you can see it gets messier. My u is equal to 5x squared. My v is equal to my e to the x. I'll move this up just a tad for you. My derivative is equal to 10x. And my derivative for v is equal to e to the x, because luckily that one stays the same. I really love that. So if I'm looking for my y prime, or you can say dy dx, that's going to be equal to, and we're back to a red pen because that's what I picked here. I'm going to be at e to the x times 10x. I have my plus over here, so I'm going to flip up and go past my plus. And I'm going to come down this way, and I'm going to say 5x squared e to the x. All right. And if I clean this up just a little bit, I'm going to move my 10x out front, 10x e to the x plus 5x squared e to the x. And we're done. So this may be a slightly easier way for you to see the product rule. If you liked this method, go ahead and watch the next video on the quotient rule, because we're going to use a similar approach with the little table so that you can split things out and slow it down just a little bit, and it's a little easier to see what you're looking at, and you don't have to do it all in your head. So let me know if you have any questions, as always, and I hope you found this helpful. Bye-bye.